Let's take a look at 12th. We are supposed to find the multiplicative inverse of this particular complex number. Let's begin once again with assuming this complex number to be z. Let z equals root 5 plus root 5 plus 3i, and we know that multiplicative inverse is equal to z bar upon mod z square. We know this. Let's use this idea. Z bar equals root 5 minus 3i and mod z equals under root of a square plus b square. What is that? Root of 14. Therefore, multiplicative inverse, that is z inverse. Multiplicative inverse, z inverse will be equal to z bar over mod z square, which is 14, which is actually equal to root 5 over 14 minus 3 by 14 I. And yes, that is my final answer for this question. There could have been another method that you could have used for finding the multiplicative inverse. What is that method? Let's take a look at that method. Another method. We'll go with the basics. We don't memorize any formulae, we'll go with the basics. What will be the basics? What do the basics say? Let z equals root 5 plus 3i. Therefore, z inverse becomes equal to 1 by z. That's multiplicative inverse will be equal to this, which can be written as 1 upon root 5 plus 3i. What next? Can we leave the complex number in this form? No, we'll not leave the complex number in this form. We'll try to convert it into the standard form. And how do we do that? We'll have to multiply this by the complex conjugate. And how do we do that? Root 5 minus 3i. Okay. This is root 5 plus 3i and root 5 minus 3i. So we have multiplied numerator and denominator by the same conjugate, complex conjugate of the complex number, root 5 plus 3i. Numerator will remain as it is, root 5 minus 3i, but the denominator, can you observe that this is a plus b, this is a minus b. We can simplify that further and get a square minus b square. Yes, this will simplify to this. And you know that I square is simply minus 1, this will become plus 9. So this is root 5 minus 3i over, this is 5 plus 9, which is 14 in the denominator, right? And yes, this will give me root 5 over 14 minus 3 by 14i. That is my final answer. Once again, yes, using the other method for finding the multiplicative inverse of this question over here.